I am Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I am going to discuss about the topic cylindrical and spherical capacitors. Under the unit electrostatic field in conductors and dielectrics, studied in the subject electromagnetic fields and waves in by the second year students in the fourth semester. Today I am going to discuss about the need of capacitor, and which is it is basically classified into parallel capacitor and non-parallel capacitor. Now in this discussion we are going to discuss about the non-parallel plate capacitor and as well as the cylindrical, spherical capacitance, and what are the derivative in the part of capacitance, and what are the parameters have to be considered while the capacitance will be there, and the applications the capacitance use. At last the summary will be discussed. The first, the empathy part, why we need the capacitance. The capacitance effect, which is nothing but it is used to store some amount of energy in a particular device. So for storing some energy we need one device, which one, that is called the capacitance. When there is a need of coaxial cables in the TV and as well as the Ethernet applications, and when we are using our mobile phone, we are need of underground power cables, so that the cylindrical and the spherical capacitance is required. And coming to the definition part of the cylindrical capacitance, which is consist of two coaxial conducting cylinder. The coaxial cylinder will be having the inner cylinder as well as the outer cylinder. The inner cylinder will be having a radius A and the outer cylinder will be having a radius B. And the capacitance, which is a cylindrical capacitance, which will be designed in the sense which is having the length will be greater than or will be equal to outer cylinder radius. And the dielectric material will be used between two coaxial cylinders. And coming to the formulas of the capacitance, which is equal to C equal to 2 pi epsilon L divided by ln of B by A, where epsilon, which is equal to epsilon naught into epsilon R. And coming to the spherical capacitance, it is also a consist of two spherical shape, two concentric conducting circles, which will be having two inner sphere and outer sphere. The inner sphere will be having a radius A and outer sphere will be having a radius B, and it is having the capacitance which is storing some energy. The capacitance formula will be C, which is equal to 4 pi epsilon AB divided by B minus A. And coming to the ideate part of the cylindrical and spherical capacitance is that coming to cylindrical capacitance, we have to choose the inner radius and outer radius of that spherical coaxial cylinder, and length of the cylinder should be properly designed, and this two inner and outer cylindrical layer, it will be separated by the dielectric medium, and the particularly dielectric medium will be chosen perfectly, and depending on this three parameters will be perfectly chosen, and the electric field will be generated. And coming to the application part of this spherical and cylindrical capacitance, the spherical capacitance and cylindrical capacitance, which will be used in underground burying cables as well as in TV applications and Ethernet applications, and it is particularly used as cylindrical capacitance and spherical shape capacitance. And the summary part of this capacitance effect is that the capacitance, which is particularly the definition part of this capacitance, is energy storage, and the types of the capacitance is parallel plate capacitance, isolated, and cylindrical and spherical capacitance. And the capacitance will be connected in the type of series as well as parallel connections, and the capacitance will be chosen for the applications to store some electrical charges in that particular devices, and while storing these charges it will be related to electric field as well as the electric potentials, and the dielectric material will be particularly chosen correctly for the capacitance. These are the references I have taken for this capacitance effect. Thank you.